Hello, myself Dr. Ajay Sharma, Department of Electronics and Communication, James Engineering Management Technical. The subject that I teach in this semester for Electronics and Communication Engineering students in 5th semester is digital communication, and the topic that I discussed today is probability of error in pulse code modulation system. In binary PCM system, or you may say pulse code modulation system, binary digits may be represented by two pulse labels. Means every binary digit may be represented by pulse labels. Label may be two label may be 0 or A volt, or A or minus A volt. A may be any value, any real number. For example, if you choose A is equals to 2, so 2 represent 2 volt, right? So in binary PCM system, binary digits may be represented by two pulse labels, and these labels are chosen as 0 and A. Means 0 is represented by 0 volt may be represented by 0 bit, and A volt may be represented by 1, digit 1, right? So that type of signal is termed as on-off binary. So in on-off binary, we represent 0 as 0 volt and 1 as A volt, right? And another way of representing this binary digits is if you choose label between minus A by 2 and plus A by 2. So in that scenario, the signal is polar binary signal. So in polar binary signal, 0 digit represented by minus A by 2 volt and 1 is represented by plus A by 2 volt, right? So in this particular picture, if you see that we have two labels, 0 and A. So 0 label represent 0 bit and A label represent a 1 in a particular bit duration, and the bit duration is 0 to T. So 0 to T that shown in this particular picture is the bit duration, and this bit duration is same for 1 and 0. Now, the binary digit 0 is represented by a signal of label 0 for the duration T of the transmission, and the digit 1 is represented by the signal label AT. So that we already shown in the previous picture. That in our case 0 represented by 0 volt and 1 represented by plus 80 volt, right? So, but what happens when this type of pulses are to be transmitted from a transmitter by a channel? Then what's happened? These 0 and 1 labels are distorted, right? Because the signal, as the signal progresses, as the signal travel through a channel, the signal is distorted. And look at this, and the channel that we have in communication system mostly is the Gaussian noise channel, right? So in this picture, if you see that 0 and A volt are distorted, so noise, because the noise mix in the signal. So this is the picture where you see that this is the case when the signal travel through a channel, the 0 and 1 volts are to be distorted. So these type of signal reach to the receiver. So here the binary labels at the receiver are normally 0 and A upon receipt of a 0 and 1 digit respectively. Means if receiver sends 0 volt, that means 0 was transmitted, and if the receiver sends A volt, means 1 was transmitted, right? So this is our case. The function of a receiver is to distinguish the digit 0 and the digit 1. This is the function of receiver. to distribute 0 and digit 1. So receivers takes the decision whether the 0 is received or whether 1 is received, and this decision actually based on the threshold that we will discuss in next slides. So the most important performance characteristics of the receiver is the probability that an error will be made in such a determination. So the characteristic of the receiver, the most important characteristic of receiver is that what is the probability that an error come in the picture, and what is the possibility of error, and if error come in the receiver, then what is the possibility? The possibility is that when the error come in the picture, the probability of error means when 1 was transmitted, receiver said 0, and if 0 was transmitted, receiver said 1, right? So if receiver sends 0 when 1 was transmitted or vice versa, then we can say that this is the error that come in the picture. This is only the two possibilities, that either receiver read 0 as 1 or receiver read 1 as 0, and this is the only two ways the error come in the picture. So what will be the probability that error come in the receiver? That we will discuss. So consider the received signal waveform for the bit transmitted between 0 and time t. Due to the presence of noise, the actual waveform yt at the receiver is yt is equal to ft plus nt. Actually, when the signal travel through the channel introduce a noise, and that noise is additive, and that noise is added to your signal. So the overall signal become yt because ft plus nt, because nt is the noise. This noise is also a function of time, is added to your signal ft, and this become yt. So ft, instead of ft, yt reached at the receiver side, because noise is mixed in the true signal that is transmitted through a transmitter. So the overall signal is yt is equals to ft plus nt, where ft is the ideal noise free signal. This is your real signal. So this ft may be represented as 0 or it may be 1. The symbol 0 transmitted means signal is absent, and 1 symbol 1 is transmitted means signal is present. So ft is either 0 or 1, right? So overall signal that is reached at the receiver is yt, which is the summation of ft, that ft may be 0 or 1 plus a noise added in from the channel. So a very simple detector could be obtained by sampling the received signal at some instant ts in the range 0 and t, and using the value to make a decision. The value obtained would be of one of the following. So yts is equals to nts, signal is absent. Yts is equals to ants, signal is present. Means if you have a 0 volt, means when 0 was transmitted from the transmitter, your yts ideal is only nts, because the receiver sends only the noise content, right? So the signal, and this nts should be below threshold. So your transmitter read as 0, because in this case signal is absent. And when signal senses something which is above threshold, and this is the case when your yts is equal to a plus nts. Look at this nts, that signal is present, right? So these are the two possibilities. Since the value nts, sorry, there is some network issue. Right. So this NTS actually is a random, because noise is random. You can't predict. That's why noise is considered as a random variable, right? So we cannot decide with certainty whether a signal was present or not at the time of the sample. However, a reasonable rule for the decision whether a 0 or 1 was received is the following. So on the basis of that, on the basis of that we decide. Means if your overall, the voltage level that the receiver received yt. So if yt is less than equals to some mu, then we receiver declared signal is absent, means 0 is received. When the yt which is received at the receiver, if this yt is greater than some value mu, which is threshold value, then signal present and receiver declare 1 received, right? So this quantity mu is a threshold which we would usually choose somewhere between 0 and a. Actually, sometimes it is the middle of 0 and a, right? So mostly we choose this threshold is in between 0 and a. For example, if your a is for example 4 volt, this is threshold is of 2 volt, right? It's a middle point of 0 and 4 volt. So for convenient, we denote yts as y by y. Suppose now this NT has a Gaussian distribution with mean of 0 and a variance of square sigma square. The average signal power is a square by 2. A is the amplitude, and amplitude means voltage. If you square the voltage, that become a power. So the average signal power is a square by 2, and a square by 2. Actually, RMS, it is a RMS value square. So if something is in RMS, means under root 2, and if you square the some amplitude, it becomes a square by 2. So it is a under root 2, and if you square a under root 2 RMS value of voltage, it becomes a square by 2, and noise power n is represented by sigma square. So the probability of error for on-off binary is therefore probability of error is equals to error function of under root s by n, where s is signal power, n is noise power. And because of this error function, this is the characteristic of error function. If s by n increases, if s by n increases, probability of error decreases. So if you there are two ways to decrease this probability of error, to increase signal to noise ratio. So there are two ways, either to eliminate noise. When you eliminate noise or you minimize noise, then noise power decreases. So the overall S by N increases. When overall S by N increases, and because of this error function, probability of error decreases, right? So this is the final expression of probability of error, which is equal to error function of S by N. This is very important, mathematical expression, so that clearly shows that the probability of error is always proportional to S by N. Means if you increase S by N, probability of error decreases. So we always want to maintain S by N high as possible to minimize probability of error. Thank you very much.